Explorers, this is your lead scientist, Miss Shirley. Today's lesson is what did you learn about preserving a stone monument? In today's lesson, you will explore the following. What did you learn about preserving a stone monument? Water can change stone monuments. This happens over a period of time. If rocks has cracks in it, we can fill it with silicone. We can prevent rocks from being weathered by water if we put a covering over the stone monument. In our reading about how water is able to change the shape of land and structures like Mount Rushmore and Great Sphinx, students can help Logan learn about why it's important to come up with solutions to prevent weathering and erosion. It takes water a long time to weather rock. In our last lesson, we explored how can wind change a stone monument. Stone monuments can be changed by wind. Workers try to protect the Sphinx from changes caused by wind. The Sphinx is much older than Mount Rushmore, and wind has been blowing sand against it for a long time. Weathering is the breaking down of rock, soil, and minerals, as well as other surfaces like building bricks and wood by wind, rain, and weather. Erosion occurs when water or wind washes or blows away rock or soil. Let's reintroduce some words that we learned for this lesson. Preserve, maintain something in its original or existing state. Weathering is the breaking down of rock, soil, and minerals, as well as other surfaces like building bricks and wood by wind, rain, and weather. Erosion occurs when water or wind washes or blows away rock or soil, and maintain is to keep the same, keep steady, keep up, or keep going. Okay, science explorers, let's learn more about the effects of erosion and weathering and what we learned about preserving stone monuments. And let's investigate and explore some questions about it. So let's watch this video.
So we're in Washington, D.C. right now. We're gonna go do a walking tour looking for the effects of acid rain on all of the beautiful monuments and buildings that you see in the city. I actually found a guide from the U.S. Geological Survey that maps everything out. So we're gonna go take some looks. First building we're going to is the Botanic Gardens. It was built in 1931. It's built of limestone, which is eaten away easily by acid in the water. And so what happens is the things that are inside the limestone that are a little bit harder than the calcite stick out a bit more and end up raising out of the stone surface a bit more when everything else falls away from it or dissolves away from it. And so that's what you see here. A little donut fossil. What's up, little guy? So now we're going to go up to the U.S. Capitol. We'll take a look at some pockmarks that are left by acid rain dissolving the calcite around harder minerals, which then fall out of place and leave little pockmarks. Gypsum is a byproduct of the reaction between the acid and the calcite in the water, and it traps dirt in there, which is why it gets dark. But then it also forms a crust which breaks off, and I think that's what we're seeing right here on the corners, where it's dark and then it breaks off. And that's just another way that the acid rain kind of eats away at the corners. And you can see the corners aren't sharp anymore, and I'm sure they were sharp when they were first laid. So right now we're at the Grant Memorial. We're right across the street from the Capitol. One of the things that happens to these bronze statues when they meet up with acidic rain is they turn this light blue-green color, which dissolves some of the bronze and it runs off, and so it stains the pedestals that they're on, and so that's what you're seeing here. This is all the acidic rain is turning it colors and running down and staining the marble, and it doesn't hurt the marble, but apparently there's no way to clean it without damaging the marble itself. So I guess they just leave it green. So we're in the Jefferson Memorial right now, and here's another example of how acidic precipitation will eat around the calcite, dissolve that, and then whatever that calcite was holding in place comes out, leaving these big gaps. So this concludes our tour of acid rain damage in Washington, D.C. But if you want to take your own, you can get more information here. And if you want to get more information...
Okay, science explorers, let's learn more about what we learned about preserving stone monuments and investigate some questions about it. In our last class, we read about a problem for stone monuments. Now you're going to get a chance to identify solutions. To preserve Mount Rushmore, workers fill cracks so water cannot get into them. This protects the sculpture. They fill the cracks with a material called silicone. Silicone is like a thick glue. It's hard and rubbery when it dries, and silicone is waterproof. It It keeps water out of the cracks. So we're going to be using some words from the word bank to fill in sentence frames starting on the next slide. In reading about how water is able to change the shape of land and structures like Mount Rushmore and the Great Sphinx, students will come up with ideas for Logan to learn about why it's important to come up with solutions to prevent weathering and erosion. It takes water a long time to weather rock. So to preserve Mount Rushmore, workers fill cracks so water cannot get into them. This protects the sculpture. They fill the cracks with a material called silicone. Silicone is like a thick glue. It is hard and rubbery when it dries, and silicone is waterproof. It keeps water out of the cracks. So, we're going to fill in the blank to complete the sentence. Use the word bank below. The word bank is change, preserve, short, or long. The problem is water can blank stone monuments. It can wash away soil or sand. The next one is this happens over blank period of time. Fill it with silicone, fill it with ice over underneath. Put a covering, blow wind. Solution number 1, if a rock has cracks in it, we can. Solution number 2, we can prevent rock from being weathered by water if we, okay? So think, science explorers, write your response. Next is fill in the blank to complete the sentence. Use the word bank below. The problem is if a rock has cracks in it, we can, and this is the word bank, fill it with silicone, over, put a covering over, fill it with ice underneath, blow wind. Solution number 2, we can prevent rocks from being weathered by water if we blank the stone monument. Think, science explorers, write your response. In our reading about how water is able to change the shape of land and structures like Mount Rushmore and Great Sphinx, students can help Logan learn about why it's important to come up with solutions to prevent weathering and erosion. It takes a long time to weather rock. As a bonus, can you come up with a way to measure whether or not stone has been changed by water over time? Think, science explorers, write your response. And to summarize, water can change the shape of rock. There are ways to prevent or slow water from changing rock. What did you learn about preserving a stone monument? Think, science explorers, write your response. Finally, what did you think of today's lesson? Okay, science explorers, today we learned about what we learned from preserving a stone monument. Until next time, ciao for now.